Good evening, everyone. Thank you very much to the Product Cycle UX team for having me this evening. I'm super excited to talk with you about one topic that is definitely in my heart, which is complex interaction in hardware and software environments. Just before starting this talk, I want to talk about myself just a bit. Currently, I'm Vice President of Experience Design at Barclays Corporate Bank. But what I'm going to talk with you this evening is related with my previous job as a head of design at Midas Console. Please feel free to contact me through LinkedIn. Particularly, this is my main social network, or Twitter. Start this talk with this big question. Why are we going to talk about hardware and software? I think that everyone of you already saw a few times this view of the spacecraft Dragon from SpaceX within the American astronauts. They were interacting with big touch screens and some buttons, and with that they drove the spacecraft itself. So hardware and software, complex hardware and software environments are already within us. Before going forward, I'm just going to show you a bit of things related with the topic. So what are the different domains where those complex interaction behave? The first one that every one of us knows quite well is car. In cars, we've got big dashboards, and this is an old concept from the 1982 within the Lancia Orca. And as you can see, there is a big dashboard with a big pad in the middle with a lot of buttons. But actually, this is something that is already here today. As you can see, this is the Python M-type car that's been released last year. And the concept inside the steering wheel is pretty similar, just with a big touch screen instead, a bunch of buttons. And actually in this car, there are a lot of more complex interactions because you can control stuff just with gesture recognitions, etc. And there is a big screen in front of the driver and also the passengers, etc., etc. But I'm not going to talk about the UX of that, just about the interactions. What happened about the airplanes? Because the airplanes cockpits of airplanes are another big area and domain. So this is a very early ages of the airplane, and in the 1916 you can see there were just a bunch of manometers and a baseball bat to manage the airplane. But just in the 1950s, 1960s, this is a DC9, but there are a lot of different options that you can have a look at in the web. The complexity started to be big, but at the same time, everything was still similar. Just a bunch of items, a lot of items in this case, and instead of baseball bat, a sort of joystick, and some pedals as well, etc., etc. But today they are starting to design cockpits like that, where there are a lot of screens that hide complex interaction and information within a joystick to drive. This is actually not for an airplane. This is a helicopter one, but I saw in the past something related with the airplanes as well. What happens in the spacecraft? So this is the first Explorer one, the Apollo 11 in the 1969 went to the moon. And actually, as you can see, there were plenty of buttons, a lot of complexity and stuff that all the astronauts had to memorize in order to manage the spacecraft itself. What happened within the space shuttle? Just the complexity went far away, a lot of extra monitors, but still everything was managed with buttons, faders, knobs, etc., etc. And this is what we already saw before. the today dashboards that SpaceX provided with the Space Dragon. It is also interesting to, if you want to double check what happened within this dashboard, because you can have a look at the Space Dragon version 2 on the web, which was a bit different from this one, with 2 big screens, a lot of extra buttons in the middle, etc., etc. So they made the iterations on the dashboard as well. And now we're going to talk about my domain, that was the audio. So mixing consoles. A mixing console is what is taking the sound from the instruments and from the microphone of the singer, etc., mix it all together and put it in front of the audience or for the recorder. So in the early 60s, this is the mixing console that the Beatles were using. As you can see, there are a lot of knobs, faders, etc., etc. What happened in the moving between analog and digital consoles is just they added a lot of extra complexities. As you can see, there are a lot of faders here, some screens, but the screens are more just an overview of what is happening in the hardware. And actually, because they had to hide stuff because there were too many channels, too many information and parameters for each channel, the screens are there in order to help to organize things. And nowadays we are in something like that. This is what I managed and I designed when I was the head of design in Windows consoles. This is a completely different concept where the actual software can manage the console completely in isolation without the hardware as well, if you want. And so the hardware is there in order to help, because in the live environments, you need to be quick to do stuff. And we are going to see later that you've got something that is related with muscle memory, etc., etc. And so it is important for sound engineers to have also hardware items. But in this case, the software is driving everything. The next step is, what are the differences between hardware and software? So hardware versus software. First of all, hardware. Hardware needs fixed parameters and controls. Each knob means something, and rather than in special cases, that knob, that button can just perform that action. And this is also why it is a real-time environment, because you touch, and when you touch a button, something happens and go. You can't control anything more than that. If you touch a knob, you move it a bit, you change the volume, or you change something. If you move a fader, you change again the volume or other parameters, etc., etc. It is something where the muscle memory works very, very well, because you can manage and drive a console, you can manage and drive a car, you can manage and drive an airplane more or less with blind eyes, because after a while you know where everything sits and you can just touch the elements and move them a bit. And if you are a sound engineer in this case, because we are talking about mixing console, you're using your ears and you can just manage stuff. So it is super important, it's super interesting that sound engineers are looking at the musicians on the stage and they are managing the hardware without even look at it many, many times. They also have some cons, like they are super expensive, because in order to design and produce hardware, you have to create something that is big. Every single prototype costs a lot. Iteration on the hardware costs a lot as well, because you have to create the prototype itself, etc., etc. It is difficult to be updated, because it is difficult to change one element to add a new one that is more efficient or more modern, or etc., etc. So you usually, when you want to change something in a car, you are just going to change the entire car. You are not going to change the dashboard of the car. The hardware is also heavy and big. And this is something that is very important in this era. Also, if you think at a spacecraft or airplanes, one of the reasons behind the movement towards the digital environment is about heaviness and size and saving space. Because of course, if you have to send to the space 10 kilos or 1 kilo, it makes a lot of difference. And in the audio environments, if you need a console that use 2 rooms or a console that can stay on my legs, it changes a lot, etc., etc. So those are important things related with hardware. And as you can see here, this is just hardware console. You can see you've got the faders, a lot of buttons, knobs and rotaries, other buttons, etc., etc. All the parameters in this case, because this is an analog consoles, are exposed, and you can manage one channel or the audio in the channel. Even again, just with blind eyes, you touch it, you know where they are, and you can memorize it, and you're able to manage it. What about software? So software can hide information, which is super important because in an era where we've got plenty of parameters we want to control at the same time, plenty of options we want to control at the same time, and we are reducing the size of the elements, so we are going to hide a lot of other things. They should be available in other ways, and the software will help in that way. It is also real time, and at the same time, it is also asynchronous. It means that you can use it for configurations, and you can perform actions that will not be reflected in real time, which is important because real time means that is dangerous. If you made a mistake, you made a mistake. Luckily, I was managing audio and not lives. So the worst thing that can happen is that the audience can't hear the audio of the gig. But if you're driving an airplane and you made a mistake, actually it could be very dangerous. It is dangerous in the audio as well, because a sound engineer can lose his job if the concert is just gone, etc., etc. The software can monitor the hardware then. So this is another important bit. It is also cheap. It's definitely cheaper than the hardware, because you have to develop it, but you have to also develop the hardware. But iterate and recreate stuff related with the software is a lot easier and cheaper. And it's also easy to update. You can update everything. You are used to update your mobile phone quite a lot of times, or the apps on your mobile phones quite a lot of times. Actually, with the SaaS services now, we are not updating them anymore because they've been updated for us. And of course, you don't have any size constraint rather than the size of the actual memory and small hardware that you need in order to drive and to run the software. And this is just an example of, again, the mixing console I designed, the software of it. As you can see, it's a big touch screen, and you can perform a lot of things, and you can see a lot of things, hide a lot of things, etc., etc. The complexity, of course, increased a lot. And now the main topic of this talk, so hardware and software interactions. It is a super interesting topic, and it is a very difficult one because there are not too many research available about it. And even if nowadays we can see a lot of new products that use this extensively, those interactions, they actually are not writing papers or articles we can read about them. I'm super curious about, for instance, the SpaceX research about them, but they are not available at the moment. I don't know if any one of you read the articles about the battleship, the American battleship that was driven by mixed hardware and software product. They actually had issues and an accident, and the US Navy decided to remove those touch screens and went back to something more analog rather than digital. Again, I don't know anything about the research that was behind that. I just know that I spent 4 years trying to design the mixing console that I'm talking about. And definitely there are a lot of other things that can be researched about and can be found and can be made better. So there are a few points related to interactions between hardware and software. The first one that to me is the most important one is that there are a lot of domains of interaction when you are interacting between hardware and software, because there is an hardware and software interaction that is not human managed. It's just what happens between the hardware and the software, and you have to see the same thing happen. Then there, of course, there is an hardware to human interaction. So as a sound engineer, I'm mixing the audio and I'm using the hardware. And also there is a software and human interaction. So as a sound engineer, I'm touching the screen and I'm managing the audio through the screen, etc., etc. And on top of everything, there are a lot of other interactions that can happen. In my case, it was the audio interaction. So audio went through the console and went to the hardware, went to the software, and all the kind of interaction that happened had the audio as a fourth layer of interactions that was in the base. But without the audio, you couldn't also even test and prototype anything, because the audio was the main part of it. It's the same within an airplane. You need something that flight, at least simulator, but should be able to fly it, etc., etc. So this is a super important bit, and this is a tiny video that show you the console in action. You can see the audio that is coming through. The meters are moving because the audio, and now we can see in the bottom here, here in the bottom, that the fader is moving because that guy is moving a fader on the screen. So this is a reflection of what happens in the software to the hardware, etc. And the same with the knobs that the guy is turning around on the screen. The second point was something that I already talked about a bit, is about mass code memory. The hardware is easy to memorize, the software is not. But we discovered that one of the reasons a lot of sound engineers are so used to skeuomorphic views and is because they can remember them quite well, because they looks like something that is related with the analog world, the hardware itself. So this is an example. The top image is a plugin, a physical plugin that you're using, and the second one is what we designed for the console. As you can see, it reminds quite a lot to the original analog version of it, and the skeuomorphism has been really well accepted by the sound engineers. Of course, it is not only skeuomorphism, because it's digital, you can add other things that in the analog world you can't. So for instance, the values of the input and outputs are only in the digital world, because in the analog one you didn't have any screen, so you couldn't see anything, etc., etc. So you can create something that helps the sound engineers quite a lot, adding stuff that are more digital to something that looks more analog. And yeah, this is an example of how the same concept, the same pattern has been used in many different areas. So the first one, the top one, is the default view for the channels, and the others are the two plugins that I designed, etc. The third point is that you've got real-time feedback, because in hardware and software interaction, you can't have any lag between the hardware and software. If I touch something on the hardware, it should be reflected automatically and in real time to the software, and vice versa. If something happens with the audio, it should be reflected in the hardware and the software as well, without any lag, etc., etc. And this is a reason because of many hardware and software products have light UIs with not too many shadows or blur, just light animation or no animation at all. That just because, for instance, in my case, I had to respect at least 60 frame rates per second. Actually, I made a mistake here per minute, but it was per second in each for any view I created. So it is super important to be super quick. It's like a game environment, if you want, in some ways. This is just a very quick example that show you that there are no animation, just it looks quite flat. So there are games we had to, and trick we had to create it in order to give the users the perception of a bit more three-dimensionality, etc., etc. The fourth point, and the last one, is about consistent interaction. You need to have a consistent interaction between the hardware and the software. If you turn a knob on the hardware, you need to turn a knob on the software. If you press a button in the hardware, the button action to press it in the software should be similar. If you move a fader in the hardware, the same movement is the movement you have to do in order to perform moving a fader on the software. The fader, the meters, we saw before the meters that were moving, they should move in the same way between the hardware and the software, etc., etc. It is super important that everything that should be consistent all across the system. And here we can see a bigger view of those knobs. As you can see, the knobs, you're using your finger around the knob. Instead, what usually you can see in audio tools where to move, to rotate a knob or a rotary or whatever, you are moving the mouse up and down and not, you're not turning it around. This is, of course, something we could realize because it is a touch environment, so you don't have to use the mouse. So we are in the end. Conclusions. The first one, it is probably the most important one, is the continuum between hardware and software is key. You need to have a continuum and a connection between hardware and software, and everything that happened in the hardware should be reflected in the software and vice versa. In order to design interactions, you need to take in consideration all the different domains of interaction from the beginning. You can't design one button without thinking how the button works in the hardware. You can't design an element that moves and show a volume change without taking in consideration what happened in the hardware, etc., etc. It is super important that you take in consideration those things from the beginning. Otherwise, you're going to redesign them many, many, many times. Mass-code memory in complex environments research still to be done. This is important, as I mentioned before. There are not too many papers available, not too many articles available about those things. A few articles and papers available are related usually with the army and particularly airplanes, and they are usually quite old. I know that there are studies that are coming through and they've been released in the last 1 year and a half, 2 years, but still there is a lot of things to be done, and it's a super interesting area for us designers. And of course, there is still space for skeuomorphism. Complex interaction in products requires long-term projects. In order to create a physical product, you need to spend time. It is not something that you can realize in a few months. As I said, I've been in Midas console for 4 years working on that project, just that project, and actually the engineering team started quite a lot before I joined the team. So just to design a mixing console is a 5 to 6 years project. If you think an airplane, if you think a car, if you think all those projects are long-term projects, and this is an interesting point to point out. And the last one is, it is definitely fun. I enjoyed every single moment I spent designing that console, and I really would love to see more designers being involved in those kind of projects, because it's an area where us as designers are super required, are super needed, but many times those projects are being managed by engineers, and even the design is managed by engineers. When I joined the company, the designers were more or less asset producer. We did something, the team did something before I joined, but we were not so involved in each single area of the design of the console as we were in the end. Not only because of me, but because of the team, and because of the entire team, engineering team, the bosses that saw how important it was to involve us. Say that, thank you very much for having me again, and please feel free to contact me through LinkedIn or Twitter.